Yeah, I'm going to go over an example of multiplying rational expressions now. I'm going to go with number 29 to start out with. So again, if you have this for homework, you're more welcome to do this example along with me and count it as your homework assignment. There are a number of strategies you can take for problems like this. I'm going to show you a couple of them. First one, some people like just going straight across and multiplying. So, just like fractions, just multiply straight across. 80x to the fourth times xy. So then you can rewrite it as, some people like doing it like this. I like this method too. Just rearrange it because the commutative property of multiplication says you can really multiply things in any order you want. So times x to the fourth times x times y. And then down below we've got y to the third times 5 times x squared. Some people just like multiplying it straight out and then dealing with the simplifying at the end. So we'll try that first. So I could go 80. Now remember, if there's no exponent, I can just put a 1 here. And when you're multiplying bases with, same base, different exponents, just add the exponents. So same base as x, add the 4 and the 1, you get x to the fifth. Then you're left with y up here. Now down below, all right, I'm just going to write things in the same order here. So I'm going to go 5, x squared, y to the third. Again, because the commutative property says I can multiply in any order I want. Now what some people like to do is they just like to simplify from here. So they would look at it, 80 over 5. Okay, if I do 80 divided by 5, 5 goes into both of them. And then I would end up with 16 on top, 1 down below. And then they could simplify x to the fifth over x to the second. Again, if you're dividing exponents that have the same base, now you subtract them. So 5 minus 2 would give you x to the third. So go right on top here. Now again, we don't have an exponent here for y, so I'll go with the 1. And I'm going to deal with my y's now. So I have y to the third, y to the first. Again, just subtract the exponents. So I could do 3 minus 1. Since 3 is on the bottom, that means my y's are going to remain on the bottom. Since, 3 is the greater exponent. 3 minus 1 gives me 2. So now I don't necessarily need that 1 there. So I can just rewrite this as 16x to the third over y squared. That is one way you could solve this problem. I'm going to show you another way. I kind of like going this way. Some people think it gets a bit, messy, hard to keep track of things. So again, you have a lot of different options for solving these types of problems. Here's what I like to do personally. I like to cross-simplify when possible. What does that mean? Okay. Since I'm multiplying, right, as I already established, you're just going straight across. But if I can cross-simplify, I can do 80 over 5, which I already did before. If you remember when I multiplied it straight out, I end up doing that at the end anyway. Might as well do it now. So 80 over 5, I know 5 goes into both of them. This becomes 16. This becomes 1. Okay. And then I can keep going here. All right. I've got y to the third down here, and y. Again, I can cross-simplify. Again, that's exactly what I did before, so nothing brand new going on here. 3 minus 1 gives me y to the second, so just get that out of the way right now. And then I'm still left with, let's see, x to the fourth. I'll do this in green. Got x to the fourth up here. X to the second down here. Again, cross-simplify. Why not? Get it out of the way before, the very end. So fourth x to the second, I can simplify that to x to the second. And now what am I left with? I'm just going to tuck my work up here. I get 16 x to the second times x, because I still have that x left over here, all over y to the second. X to the second times x to the first gives me 16x to the third. And guess what? It's the same exact answer as I got before. So you can do your simplifying before you actually multiply it all out by cross-simplifying, or you can multiply the whole thing out and then simplify at the end. But that's a nice, easy way to, or maybe not an easy way, but these are a couple of different methods that you can multiply rational expressions and ultimately get the same answer.